Hey everyone, and welcome to section 6.3, which deals with factoring special products. So we're going to talk about perfect square trinomials, difference of squares, and sums and difference of cubes. So first of all, basically a trinomial that can be factored into a binomial squared is what we're talking about, okay? And these trinomials have a special pattern, okay? And we call that the perfect square trinomial, or PST, okay? So this is the pattern. So let's say you have a binomial, let's say a plus b squared, right? If we write here, so let's say 3x plus 4, where a is 3x and b is 4. And if I was to multiply this binomial out, I would notice that my trinomial is a squared plus 2 times a times b plus b squared. In other words, 9x squared plus 24x plus 16. So this is multiplying it out, right? So multiplying. So if we can take a trinomial and recognize this pattern, then it's easy to factor. Okay, so factoring would be going in this direction. Okay, so let's see if we can do that. I'm sure we can. So how do we do that? First, we need to see the trinomial and check if it fits the pattern, a squared plus 2ab plus b squared. So we would ask ourselves, is the first term a perfect square? Is the last term a perfect square? Okay, fine. And then in the middle, so if I take the square root of the first one and the last one, multiply them together and multiply that product by 2, then you have a perfect square trinomial. So let's go ahead and do that. So first thing is this first term a perfect square? If I take the square root of this, that's going to be 3x, right? So yes, it's a perfect square. In other words, it's 3x squared. Okay, is this last term a perfect square? Can I rewrite that as a perfect square? And I can. 2 squared is 4, right? So now that I have that, this would technically be my a and this would be my b. So what is 2 times a times b here? So that's 2 times 3x times 6. So is that, why did I put 6? I meant, I meant 2. I think I saw that b and I said 6. Okay, so 2, which is the 2 from the perfect square trinomial pattern. Okay, then the a, which is 3x, and then the b, which is a 2. Okay, so then that ends up being 12x. So yes, it is. So that's perfect. So that's plus 2 times 3x times 2. So that fits the pattern. So now we can factor it as a trinomial. That's just going to be a, because this is a plus, and then b, which is 2, squared. Okay? So alternatively, we would have done, why is this such a cool thing? We would have to factor using AC method or what have you, but now we can just simply recognize the pattern and we're golden. Okay, so let's go ahead and do another one. Okay, so 81y squared minus 72y plus 16. So what's the square root of 81y? So if I was to write that as a perfect square, it would be 9y squared. And then, so that's a perfect square, so this would be technically my a. 16 can be written as a square, 4 squared, right? So then that would be b. This 4 would be b. And then since this is a minus, it would be, so the formula is 2ab plus b squared when it's a minus. So what is minus 2 times a times b? So minus 2ab would be 2, and then a is 9y, and then b is 4. Okay, and then this would be plus. So is 2 times 9y times 4. So 2 times 9y times 4. So negative 2 9y times 4 ends up being negative 72y. So yes, it checks. So since that checks out, it's the same. We can go ahead and just factor. So that's 9y plus 4 squared. Okay. So ultimately, as long as it fits the pattern, you can go ahead and factor it. Let's do another one here. So in this case, notice that you have an x and a y. So if I was to write this as a term squared, that would be 6x squared. And if I was to write this as a perfect square, that would be 7y squared. What is 2 times times a times b? Okay, so that's going to be 12 times 7, which is 84xy. So is that the middle term? Yes, it is. Right? So that would be plus 2 times a times b. Plus, okay, so then again, a squared plus 2ab plus b squared is what we're using. So since this fits the pattern, I can go ahead and just write it as a binomial 6x plus 7y squared. Okay. One more. Okay. Now in this case, we have a GCF. Okay, you see the GCF here? So we can factor out GCF. I think we can factor out a 4 as well. Okay, so if we factor out a 4y, what do we get? We get 25x squared minus 20x plus 4. Okay, so this looks like a perfect square trinomial in here. So kind of leaving, like, we kind of ignore this 4y by now, but we know, we kind of have it in the back of our mind. Okay, it's there, but it's, you know, outside the parentheses. What we're really doing right now is zeroing in on this, okay? So kind of just zero in on this and solve it using this technique that we just learned. Okay, so let's rewrite 25x as 5x squared. This 4 is 2 squared. And then this minus 20x is that minus 2 times 5x times 2. Okay, so that does fit. This is equal to the middle. Okay, so since they're equal to each other, I can go ahead and remember the 4y stays on the outside. I can write this as a single binomial squared. This is a minus because this is a minus. So it's 5x minus 2 squared. Okay, and then the 4y, of course. Okay, the next one is one of my favorites, is difference of squares. So remember the pattern when we have the conjugates, we introduced this as conjugates. A plus b, a minus b, that's going to be a squared minus b squared, okay? So we're going in reverse. If you notice that you have a binomial where both of the terms, it's the difference of 2 perfect squares, you can factor it into a plus b, a minus b form, okay? So the pattern is like this. It has to be a difference, and then these have to be perfect squares, okay? So remember your perfect squares, of course. So here we have 64y squared minus 1. Oops, what did I do? Where did I go? Here it is. So I can rewrite this as 8y squared minus, and then 1 is the same as 1 squared. So since that's the case, this is a, this is b, that's going to factor into 8y minus 1, 8y plus 1. So again, if you want to check your factoring, multiply this out, you'll find that you get back to here. Okay, let's do a couple more. So then this, once you start recognizing it, it's a lot easier. So this is 12x squared minus, and then so I'm writing it in these parentheses in this form. But if you could recognize it without having to write it this way, then by all means go ahead. So that's going to be 12x plus 7y, 12x minus 7y. It doesn't matter if the plus or the minus term comes first. It doesn't matter. So how about here? Looks like we have a GCF to factor out. Okay, so here we know we can factor out. Looks like a y squared. And can we factor anything else out from a common factor from 243 and 48? So let's think for a second. 243. Okay, so 243 can be divided by, let's see, so factors of 48 are 6, 8, 12, 4. So 3 factors into both of these two terms, okay? So, right. So if we factor out a 3y squared, so GCF here was 3y squared, we would get, let's do that first. So remember, GCF is always first. So again, somewhere GCF is always first. So if you have a GCF, you should factor out that first, okay? So 3y squared, that leaves us with 16x to the power 4 minus 81. Okay, so this is a perfect square, this is a perfect square, okay? So 3y squared, so if you rewrite this, this is going to be 4x squared, and then that's raised to the power 2. Okay, because notice that this is a fourth term, not a square term. So then, so minus, and then 81 is 9 squared. Well, looks we're going to be factoring this a lot. So then this is going to be, so we leave the 3y squared on the outside, don't forget him. So then that becomes 4x squared plus 9, and then 4x squared minus 9. Well, are we done here? Okay, usually I would say, yeah, we're done, but wait a second. What do we notice about this and this? These are perfect squares. 4x squared can be rewritten as 2x squared, and then 9, of course, is 3 squared, okay? So we can factor that even more, okay? So just zero in on this part, you know, if it was like, think about it as if it was a new problem, and then the rest just comes along for the ride. So we leave that alone. Of course, the middle one is not factorable because this is a sum of squares, and that's not factorable, okay? So then here, we would rewrite this as 2x plus 3, 2x minus 3, and now we're done. Okay. All right. Very good. Okay, and then the last thing is sum and difference of cubes. Okay, so if you have 2 cubes, you can factor it using this pattern. Okay, so it's if it's a cubed plus b cubed, it's the sum of a and b, and then a squared minus ab plus b squared. And then if it's a cubed minus b squared, the first one is a minus b, and then the next one is a squared plus ab plus b squared. A way to memorize what sign goes, because the numbers and the letters, the letters and the exponents are the same. Factoring for a plus b and a cubed plus b cubed and a cubed minus b cubed. Notice that the sign of the first factor is the same, and then the next sign changes, and the last sign is always positive. Okay. So we just have to see if it fits the like once we identify what the cubes are, it's just plugging it in, honestly. So again, remember, it's a cubed plus b cubed is equal to a plus b, a squared minus ab plus b squared. This is not a perfect square trinomial, by the way, this one, because it's missing a 2. Okay, and then the general form for the difference of cubes, a minus b, a squared plus ab plus b squared. Okay, so then the trick is to identify a and b. So x cubed plus 64, you get x cubed, so x is already cubed, plus, and then 64 is 4 cubed. So in this case, a is x and b is 4. Okay, so you have a is x and b is 4. Then we're going to write, so this is a and this is b. Okay, so a squared, a plus b, so then x plus 4, right? X squared minus, and then 4 times x is 4x, right? Or x times 4 is 4x, plus 4 squared, which is 16. But we'll just leave it like that. So you'll see here, this is a plus b, a squared minus ab, this is a and this is b. But we write the coefficient in front of x, plus b squared. And that's the formula. So then if we want a final answer, x plus 4, x squared minus 4x plus 16. Okay. So same one here. Let's go ahead and factor 27u squared cubed. So that's 3u cubed minus 125v. So that's 5v cubed. All right. So it's the same thing, except that we're going to use a plus b, a minus b, sorry, because it's a minus. So a minus b, a squared plus ab plus b squared. So then let's go ahead. So this is a and this is b. So 3u minus 5v, then it's going to be 3u. So notice the parentheses, the usage of parentheses. It's a lot easier when you're simplifying it. It may take you a little bit longer, but it's easier, trust me. You will be more accurate if you write it out this way. So a minus b, a squared plus ab plus b squared. Okay, so then simplifying that, we get 3u minus 5v. This becomes 9u squared plus, and then this is going to be 15uv and then plus 25 v squared. All right. Okay, so that's pretty much it for this section. Good luck, happy studying, and I will see you in the next video.